All right, so number 14 wants us to find the critical numbers and use the second derivative test to find the max and min. So as soon as I see that I need to find critical numbers, that means I need to do first derivative. And then there's two things. I need to find where the first derivative is 0 and where the first derivative is undefined. That's where critical numbers occur. And then I'm going to use the second derivative test for concavity, because concave up means opening up, concave down means opening down. So if the graph is opening up at a critical number, it will be a minimum. If the graph is opening down at a critical number, that will be a maximum. So that's where the second derivative comes in. But these are kind of weird because it's a little different than using the first derivative test. So first thing I want to do is I'm going to have to do quotient rule here. So when I do quotient rule, the derivative is going to be the bottom times derivative of the top minus the top times derivative of the bottom. Now, if you don't remember how to do the derivative of a natural log, you take whatever's after the natural log goes in the denominator and the derivative of that goes on top. And then that is times or all over the bottom squared. So this right here is going to be my my derivative. Now I'm going to simplify that. So when I simplify that, I got the natural log of x minus 1 all over the natural log of x squared. So that is my first derivative. So now I can find my critical number. So I want to find where f prime equals 0. Again, you can set this whole thing equal to 0, but it's a lot faster if you just take the top part equal to 0 because, or if you take the numerator equal to 0, because if you put that natural log of x squared down here, when you multiply that over, it goes away. So you don't have to worry about that. So I want to find where the natural log of x equals 1. Now I'm solving for x. So what gets rid of natural log? Well, that is e. So I take e to this power on the left side and e to the first power on the right side, and those cancel out. So I get x equals e to the first power, just e. So there's one critical number. The other critical number occurs where this function is undefined. So that's where the denominator equals 0. Okay? And I guess I should go ahead and put squared there. That's kind of where I messed up on that example on the last one. But you square root each side. This is why it didn't matter. I left the square off, or it was a cube actually on the problem I messed up. But I would have cube rooted 0, which is still 0, which doesn't matter. So I actually had this deal right here. And then I'm going to e to the power and e to the power, and these cancel out. So I get x equals 1. Now you got to be careful when you're dealing with natural logs, because when you deal with natural logs, the domain is greater than 0. So x has to be greater than 0. You cannot do the natural log of 0. So 1 is fine. So I've got these two critical numbers. Well, something that we need to, just to make sure you're aware, e to the first is approximately 2.718, ... That's Euler's number, which was a scientist, I think it was from Germany, and he used to study nature, and he found things in nature reproduced kind of by this exponential function right here, e to the x. So that's about this number. So anyway, those are my critical numbers. So now what I want to do is find out what the concavity is at these two places. So concavity has to do with the second derivative. So I need to do the derivative of this. So again, it's going to be quotient rule. So when I do the second derivative of this function, I'm going to take the bottom times derivative of the top. So the derivative of natural log of x is 1 over x. And then derivative of -1 is 0, so don't worry about it, minus the top times derivative of the bottom. And I wish I'd have given myself more room, because, let me scoot this over, I have to do chain rule, which takes up more space. So when I do the derivative of the bottom, I'm going to take that 2 to the front, leave the inside the same, lower that power to a 1, which that's it, and then times the derivative of the part inside, which is that natural log of x. And that is all over the bottom squared again. Okay, so what I want to do now is find, well, let's go ahead and simplify this thing. I'm going to get the natural log of x squared over x minus, let's see, I guess I can distribute this over to here, it doesn't matter. So I got minus, I'm going to have an x in the denominator. 2 natural log of x times natural log of x is 2 natural log of x squared. And then minus 2 natural log of x all over the natural log of x to the 4th power. I don't know if I should go ahead and simplify this or just plug in. We'll do it. We'll plug in a minute. So let's go ahead and combine these like terms here. So I got natural log of x squared minus 2 natural log of x squared. That's minus 1 natural log of x squared. And by the way, if somebody sees me making a mistake, will you please yell it out to me? So I got this deal right here. Oops. Yeah, that's right. Okay. So what I want to do now is I want to find out what's the value of x is the second derivative of e to the 1st power. So it's going to be a negative natural log of e squared minus 2 times natural log of e all over natural log of e to the 4th power. So when I solve that, these natural log of e's reduce out, so this is 1. So this is going to be negative 1, and again, these reduce out to 1, minus 2 all over 1 to the 4th. The important thing is this is going to be a negative, which means concave down, which tells me at this place, we're doing this. So this is a min. Then I'm going to do the f double prime of 1. So I'm going to stick that in here. So I'm going to get negative natural log of 1 squared minus 2 natural log of 1 all over natural log of 1 to the 4th. Well, the natural log of 1 is 0. So actually, maybe I should have go back up to the original problem. Looks like to me this is going to be undefined here. Yes, this is going to be undefined because if I do natural log of 1, that puts a 0 on the bottom, which is not possible. So I get nothing from this. This is undefined. So I get nothing from that. So what I have here is I have a relative min when x is negative 1. Now I got to go back and look at the directions again and see if I'm supposed to call it, get a point for it. Find all critical numbers. That's a location. Okay. Well, it doesn't really say if I'm supposed to find the y value for it, but I'm going to anyway. So I know there's a minimum here. So to get the original problem was x over natural log of x. So I'm going to go ahead and erase that stuff I just marked out. Oops, maybe. So I'm going to go ahead and find the y value that goes with that. So I'm going to do f. If you remember, f of x equals x over natural log of x. So if I do f of e to the 1st power, that's going to be e to the 1st power over natural log of e. And again, these give you 1 because these cancel out. That's the exponent. So this is e. So I have a maximum. So f, I said a max, has a min, has a minimum equal to e from this e at x equals e. And then you would say my second derivative test, because we did the second derivative test right over here. Okay. All right, so I got asked will they tell us the domain, what the domain is, or are we just supposed to know that? Well, for natural log of x, you're supposed to know. For natural log of x, y equals natural log of x, you're supposed to know that the y-axis is an asymptote and that the graph of a natural log follows up along that y-axis and usually goes through 1, 0 and takes off like that. So for natural log of x, you're supposed to know the domain is 0 to infinity, not including 0. Sometimes they give you the interval, but if they don't give you an interval and it doesn't have a domain restriction, then you're supposed to assume it's from negative infinity to infinity. Let's see. Does anybody else have any questions on anything? Anybody else got anything? Okay, so you want to watch the 5.8, 5.9 notes and practice those problems. Pause the video, practice the problems, and then watch the video, see if you get the same thing I got or something very similar to what I got. And I'm going to do, I'm planning on trying to set up a matching graphs activity. And then you want to finish up the 5, 6, and 7 notes, or 5, 6, and 7 worksheet. And tomorrow you're going to have 5, 6, 7 quiz. So if you got any more questions off this, you're going to get asked those tomorrow. And then we're going to have a quiz after we're done with class tomorrow. And I am hopefully going to get the 5, 10, and 11 notes done today and post those. And then I'll have 5, 12 notes and we'll be done with all the notes. So if you guys don't have any more questions, I'm going to call it a day. Last chance. Anything else? Please upload these to Canvas. Do not email me pictures anymore to my email. I got too many of those, so we're going to just go straight to Canvas. Well, have a great day. It's good to see you guys back. Hope everybody's staying healthy, and I will talk to you tomorrow. Have a great day.